Susan for that. Next up, Dr. Andrew Smith from CERAM over in the UK, Leaving Your Mark, Footprinting a Business. Andy? All yours.
Good morning to you all. I'd just like to give a stark warning maybe. In the UK and in Europe, we're much further down the line of the regulatory requirements and the stuff that Terry and Susan have just been talking about. We're actually already 10 years down the line on most of these. We have the limits. My advice is keep fighting your corner, because beating them with facts is better than beating them with fiction. And the one thing that the industry within the UK and particularly within Europe as a whole has come together, and they've generated enough actual scientific fact to defend the position that's being made. So more power to your elbow with that. When all else fails, look at the threat as an opportunity. And what I'd like to present here today is some of the work that we've been doing, which is really starting to look at the things that we have to do and how to turn them to a benefit. And I'm sure you've all come across the phrase of footprinting. And footprinting really is another way of evaluating what you do, how you do it, to come up with a process-type optimization. But it's done within a framework that is dictated by others. So the two areas I'll present today are some studies that we've been doing over the past few years in the UK, looking at carbon footprinting of GHG, greenhouse gas emissions. And then the second one is one of the new things for us is, believe it or not, we have issues with water in the UK. If any of you had had the pleasure to visit us this summer, you wouldn't believe it. But I think there's a trade-off with what I can do with Tuck. I'll do you a deal. You can have some of our cooler weather, and we'll have a little bit of your warmer weather from Texas, because the UK so far this year has not had really a summer until the day I departed, which was up at 84 degrees. So let's have a look, see what we've got. Well, this is going to be a short presentation because UK generic carbon footprint for all of the brickworks in the UK is 244 tonnes of CO2 equivalents per tonne of product. That's what the carbon footprint does. That's what it asks you to do. Come up with a number. But there's one heck of a lot more information behind that you can actually start to take the cake and cut it into different slices, so you start to understand how you're doing, what you're doing better. So the headline figure, and the headline figure I should stress here, this was based on 14 generic, what's deemed to be representative brickworks out of the 60 that we still have operational in the UK. And that 0.244 tonnes, or 244 kilograms of CO2 per tonne of fired ware, is a number that means a great deal, because it's actually less than concrete, which, don't tell those. So, let's have a look. As you can see here, the blue stuff, by the way, is the sea. The bit in the middle is the dots, are where the works are. As you can see, you know, this distance between London and Manchester is 200 miles. So, you know, we're a relatively small island compared to you guys. In fact, I think the UK fits into Texas a number of times, so, you know, let's put it into context. But we use 14 works, and the little dots here with the different colours represent where the works are located within the UK. As you see, a dominance there in what we call our Midlands, and a couple down in the south coast operating the wheeled clay. We looked at 4 different types of clay, although there are somewhere in the region of about 30 odd different actual types of clay that we use to make heavy clay products, which are obviously bricks, pavers, roof tiles and clay pipes in the UK. The dominant ones are the shales, the carboniferous shales, so what you guys would call probably Mississippian horizons, we call the carboniferous. But they're the coal measure bearing strata within the UK. The Etruria marl is a subgroup of that. It's the Rolls-Royce of clay making in the UK. It's the one that everybody wants, but not everyone's got. Then we have the Kuiper marl, which is a predominantly lime-rich and gypsiferous type of clay. And then we have the Weald, which is the youngest of the clays here that we're dealing with down in the southeast of the country. Typically used for stock-type bricks, so soft mud process. All I've done here is change the colour of the dots to just show you here which are the extrusion works and which are the soft mud works. So the carbon footprint that we were asked to have a look at was what's known as those of you that are in the know with regards the terminology of the LCA or life cycle analysis type studies. This is a cradle to customer. So it's all of the raw materials, all of the production, including site office, which is classed as a scope 3 emission, transportation then from the production facility to the first stage, which is the customer or the merchant's yard, and also a portion of head office function, if that's not on the particular site. So within the scopes of the ISO 14064, or the WRI, the World Resource Initiative, which is a scoping way of actually looking at all of your GHG emissions. So we have these three scopes, essentially. One is the emissions from your combustion of fuel-based emissions from your site, so the burning of natural gas, the burning of any oils, etc. Then you have the emissions from your mains grid supplied electricity. So effectively you have to account here for the transmission losses in the grid and also the amount of electricity that you're using. And that's on the basis of the actual emissions as a result of generating that electricity at the power plants. And in terms of the scale, the majority of UK electricity is generated using natural gas rather than traditionally they were all coal-fired. And our nuclear portion is probably at around about 8% at the moment. Although we do have a lot of windmills going up. So the carbon footprint, what do we look at? Well, we looked at raw materials, and that's the quarrying of those raw materials, the transportation, the additives that are going into the brick bodies, such as the barium carbonates, the pigments, the stains, the sands, and we're looking at the thermal breakdown processes that give us emissions. Then we're looking at the production process, which is essentially the energy that we put into the kiln and the dryers, and running all of the equipment, so the electricity, the natural gas, the fuel oils, etc. And then we have the site office, the transportation of the product, and the head office. And put into context here, delivery, the average distance that bricks travel in the UK is about 80 miles from factory to the user. So we're not talking about huge transportation issues here. Then finally, the contribution from your head office. And boy, don't those head offices take up some energy. Go all that aircon, all that heating, all that hot water. But let's put it into context. These are the 14 works, and I've tried to break them down. They're broken down here on production tons. So you can see here we have the four main players in the UK are represented here: Wienerberger, Hansen, Mittelmersch, which is the only UK-owned conglomerate of brickmakers here. All the others are owned by other European partners. Wienerberger being Austrian, Hansen being owned by Heidelberg with German, and Ibstock are CRH, which are Irish. Well, we like to be European in the UK with a small e. So we have a number of works there, they're all identified. So to put into context here, we've got everything from about 168,000 tonnes production per annum down to 32,500 tonnes annual production. Putting that again into context, UK format sized bricks, 215mm by 102 by 65. We're looking at about production from about 1.5 million bricks per annum. 1.5 million bricks per week down to about just shy of 300,000 bricks. So we've got a range here of size of works that we've looked at. We've got a range of different manufacturing processes, and we've got a range of different raw materials. Let's throw those all into the cooking pot and let's see what comes out. So when we break it down, these are the contributions from the 5 main components: raw materials, production, site office, delivery, and head office function. Immediately you can see here that site office, delivery, and the head office function are negligible in terms of the pieces of the size of the cake, whereas the raw materials and the production are the ones that really eat into your carbon emissions. Well, there's a surprise. So that's the average there for the UK brickworks, this generic single brickworks. If we start to break it down now by looking at the data and look at the extrusion works versus the soft mud works, hey, look at these. The numbers in the brackets at the top give you an indication. So 245 kilograms per ton of product for the extrusion and 243 tons of kilograms of CO2 per ton of product for the soft mud. So what's that telling us? Well, your two processes here are actually not giving that much of a difference. They're about comparable. Is there anything else we can look at with the data we've got? Well, let's have a look at clay type. We've got the shale, the Etruria marl, the Kuiper, and the Weald. And if you look at the numbers again in the brackets, you can see that there is quite a difference. So, for example, the Etruria, on average, are about 200 kilograms per ton of product carbon emissions, whereas the Kuiper is up at 290 kilograms. So there's a material difference there. Again, look at the sizes of the pieces of the cake. And again, if you concentrate on the blue and the reds here, the raw material components versus the production, so the energy-related emissions, are very different for the different types of clays. So we take something like the Etruria marl there on the top right-hand side, and we can see that the majority of the production, the emissions are related to the production emissions. Whereas down on the Kuiper, bottom left, there's much more coming actually from the raw materials. And that's predominantly because the Kuiper has a lot of lime in it. And the one thing that we have to account for in the UK and in Europe on the emissions is actually called process emissions, which relates to emissions from the raw materials as well as the energy. So we get hit by a double whammy. Not only is it the energy we use, but we also get hit by the CO2 emissions from the clay itself. So we have a look at a particular extrusion process, and then we have a look at a single clay type, such as the shale. And you can see here the 3 works that operate extrusion and shales, they have a bit of a difference. We've got one works there at 240 kilograms per ton of product, and the bottom one in the middle down at 214 kilograms, or 0.214 tons. But essentially the profiles look very similar in terms of the proportions, so raw materials to process emission. If we then have a look at extrusion compared to soft mud for the same clay, in this case the Kuiper marls, the one with the high lime contents, we can see that some of the extrusion processes versus the soft mud process have very different profiles. And some of these relate to whether the levels of lime that are particularly present within the clay itself. So we've got everything there from 336 kilograms per ton products down to 259. So we're starting to see some differences here on a site-by-site basis based on process and raw materials and production type. If we look at the Etruria, well, what does that tell us? Well, if you could have Etruria in your yard, that's what you'd have. Lowest levels of emissions. They're predominantly controlled by fuels, so they're the ones that you've actually got the most control over. If your raw material is coming in, you haven't got that much, apart from in the quarry, of actually going for lower CO2 emitting materials. And then if we have a look at the Weald, again, the Weald is one of these clays which has quite a lot of fossiliferous material in, so it's got a lot of shell fragments. And again, if you've got something, if you're producing there with a product that you're putting a large amount of body fuel additives into, again, you have to account for those if they're on the list of fuels that you have to account for in GHG. Then you're up at around 300 kilograms, so significantly higher than the national average. So what are the lessons learned here? Well, raw materials have a significant part in terms of your carbon emissions. If you have to account for them, as we do in the UK, then you have to give it some thought. You know, one point I would say is, do we really need to make buff bricks out of red clay? Do we have to penalise ourselves? And let me put this into context, some sort of context. Not only do you have to pay for the fuel in the UK, but as of this year, well, shall I say, as of 2012, you'll also have to pay for the carbon you emit on a sliding scale. And at the moment, the UK brick industry has an 80% exemption of that level. But that's a sliding scale that will go down to 0 by 2020. So every tonne of CO2 that you emit, you will end up having to pay for in some form of taxation. So that means that the price of carbon has become another metric that you need to look at if your business is to thrive. Every tonne of carbon you can save, either by process efficiency, fuel efficiency, switching to fuels that are non-taxable, is obviously something of great interest to the UK brick manufacturers. And if you can avoid making products where you're actually increasing the amount of CO2 going up the stack, then surely that is a way of actually mitigating these costs. Is it really efficient to haul clays from one end of the country to the other? Well, if we do it by road, probably not. So do we have to look at haulage by freight on the rail network? It hasn't really been used in the UK, and it's not really likely to be used. But what are the other things we can look at? Well, let's look at carbon neutral fuels. They're not actually carbon neutral, but in the eyes of the taxation fraternity, they are, because they're seen as renewable or non-impact. They still put CO2 up into the atmosphere, and I'm sure the atmosphere can differentiate between fossiliferous CO2 and renewable CO2. But I haven't worked out how you do that. But there must be better people than me in governments that actually do know the difference. So we're looking at the moment at things like syngas, synthetic gases, landfill methane. Well, we had a presentation yesterday that really extolled the virtues. If you can get landfill methane and you can use it and it's mature enough, then use it. Because in the UK, you'll be paying tax if you're pulling it off the national grid for the natural gas. Biofuels. If we can use sawdust, yeah, great. If we can use other fuels, great. But bear in mind, as Susan highlighted there, some fuels, some of these alternative fuels that you may be offered, and one of the things that we look for right on day one when they come in the bags is, what's the chances of them producing dioxins and furans? Because if you think your limits are low, you ought to have some of ours. So the second thing, and the thing that we've developed over the past 18 months or so, and particularly within the ceramic sector as a whole, is water footprinting. Well, to most people, water, and specifically within the brick industry, water is not one of those major issues, but it is a vital component to the actual process of manufacturing bricks. If your clay is not plastic, if you haven't got enough water in there, it's very difficult to actually produce a brick that holds together in the green state prior to firing. And what we've been looking here is trying to look at water footprinting in a holistic way to see whether or not there are ways that we can mitigate the amount of potable or mains drinking water that factories use, rather than the use of lagoon water or recovered recycled water. This is the UK's Environment Agency map for England, showing the delineations here in the boundaries that you see on the map are the water supply companies that supply different regions of the country. And needless to say, those areas in red are the ones that are under what we refer to as water stress. And this is the provision of water, drinking water, potable water, that comes out of your tap when you turn it on. Funnily enough, that's where the majority of the population of the UK are based, southeast of England. There's probably about 45–50% of the population within those red areas there. So there's a high demand, and who wants to go into the bathroom in the morning, turn on the tap, and for nothing to come out? Even worse now in the UK is that brickworks are being threatened with actually having their water supply turned off in periods of drought. And if you're a brickmaker and you're trying to make brick and you're reliant upon water coming out of the mains and you can't have that water, all of a sudden your process stops. So what we're looking at the moment is understanding actually how water critical some of these operations are. Let's put some things into context. 1 cup of coffee, 330 litres of water to make that 1 cup of coffee. It's not the kettle, I've hastened to add. It's not the size that you need to make 1 cup of coffee. But that's the impact of actually producing the coffee as an agricultural product, processing it, freeze-drying it, and delivering it. 1 glass of milk, 200 litres. That's basically keeping the cow going. 1 tomato, 13 litres. Now, I'm not sure whether that's what we call a beefsteak, which are about that big, or the little cherry tomatoes, which are about that big. Pint of beer, 170 litres. And if that cow then goes on and becomes a hamburger, 2,400 litres of water. So what does that information tell me? Drink beer, less water impact. If you break it down, 65% of all of the water you as an individual consume, me as a Brit consumes, is based on the food that we eat. 30-odd% comes from manufactured goods that we use, 4.2 domestic use, so if you go to the bathroom a few less times, that number gets better. However, 0.2 of it is actually related to drinking water. So the question comes here for industry is, how reliant should we be on drinking water, quality water, for our processes? This one will frighten you, I hope. But let's put it in a context. A family car requires 440,000 litres of water as part of its manufacturing process. This is embedded water within it. That's 440 tonnes of water per car required. It actually stops to make you think, particularly when we're now looking at producing a lot of our agricultural products overseas in water-stressed parts of the world. And we're shipping out manufacturing processes overseas to water-stressed parts of the world. It may be helping us in the short term, but unless we get a handle on the actual way that we use water and the impact of that water, then we could be just storing up problems for ourselves in the future. Or in the case of what we're doing probably at the moment, is we're going for the lowest buck, but we're exporting the problem and it becomes somebody else's problem. So what we've done is we've looked at a number of different ceramic processes, 2 of which were brickworks, 1 soft mud and 1 extrusion process. The Sandown works is operated by Wienerberger. It's an extrusion works. It works on a Troyer Marl. It's about 1.1 million bricks a week, so it's a 55 million brick production per annum size plant. 31,670 meters cubed, equivalent to a ton. So 31,600 tonnes of water used in that production process, of which 17,000 tonnes comes from the raw materials itself, and the balance comes from mains water. So this is potable drinking water that's been through all of the processes, but we're dumping it into brick manufacturing. Ellis Town, operated by CRH, or Ibstock as they trade in the UK, is a soft mud works. It's a smaller works. It's only 350,000 products a week, so it's about a 16.8, 17 million brick a year production facility. 23,000 metres cubed of water, and the breakdowns you see there. So 5,000 for all raw materials, 13 from mains, and the balance there coming in from the quarry. The interesting thing here is that both of them have rather significant quarries with lagoons, and therefore there is the potential here of reusing lagoon water rather than going for mains water. Ellis Town is the only one that does it. So here's the Sandown Works. It's the aerial shot looking down on the works. The works is down in the bottom right here, and essentially the boundary that the operating site has is essentially where you see the dirt roads circumference around the site. So the works is slapped next door to the quarry goes down, and you can see that there are a couple of lagoons actually within the quarry itself. As I alluded to earlier, it does rain in the UK occasionally. We do manage to fill lagoons occasionally, but we also have very stringent regulations with regards what you can take from those lagoons, because the Environment Agency see this as another way of getting the water back into the ground so we can then pump it out and process it for drinking water later. So ground recharge is one of those areas that we have to be quite careful with. And what we've developed is a water footprinting technology, or water footprinting methodology, should I say, because there's no real technology involved here, it's just an auditing process. And if you present it here as a Sankey diagram, then you can see the relative flows within your process. So we've got clay coming in at the top left. It goes through the different processes. So the clay prep side of things, the mains line, the shredders, goes into the mixing process, down into the extrusion process. And then lo and behold, guess where most of the water comes out? In the dryer. There's a shock. We weren't really expecting that. But the question is that water that's coming out of the dryer potentially usable? I'll leave that one for a moment. Here's the Ellis Town Works. The brickworks is sited in the bottom right-hand corner down there, down by where it says the B road number, the B585. The big operation you see there in the centre of the field, of the picture, is actually a very large concrete plant. And the brickworks quarry is to the north of that, on the top side of the image. So here we have a brickworks making clay products separated from its quarry by a concrete works. But we do have a pipeline that runs from that lagoon into the brickworks. It's a soft mud plant, so the balance of any water required, and therefore minimising the amount of take from the actual mains water supply itself, is done here by taking from the quarry water itself. Being a soft mud works, it also needs to use a recirculating system to actually wash out the mould chain. And here this is a closed loop system, so all it does is tops up, a bit like a domestic system. So we're recycling water already in one part of the process, but the potential for recovery is a lot greater later down the process itself. Somewhere in the order of about 16,000 tonnes of water potentially that we can recover. Is the technology available? Well, yes, it's not rocket science. All we've got to do is put a condensing unit on the exhaust ducts coming out of the dryers. Even better than that, there's technology available now where we can use not only heat exchanging principles, but we can also recover the water as a byproduct of that process as well. So there is technology out there There is technology to be able to get the water back in a meaningful way at a relatively low cost. The question then is, what do you do with your 16,000 tonnes of water? If you don't pump it into your quarry, can you pump it into a holding tank? So here's a thought. Will all brickworks in the future have a swimming pool attached to them? It's a thought. I'm not quite sure you'd want to go for a dip, though, every morning in it. What we've learnt from this exercise, and this really comes across the board, is that at the moment the price of water in the UK is not cost effective to have major capital investment. However, in the future there may well be scope for doing this. The data is limited. Most of the meters that we have are the mains meter that comes into the factory. That's it. Water is then distributed through the pipes. We don't really know what users, what, where and how much. So the thing there is, do we need better control and monitoring of the types of water, the places where the water is being used? One of my colleagues in one of the major companies said to me when we looked at this, is that, well, we know we've got 3 meters. So there are 3 mains water meters coming into the site. We can only account for the amount of water we use from 2 of those. We don't know what the 3rd one is actually telling us. A little bit of investigation showed that they were supplying water at their cost to their neighbour. So getting a handle on actually what you use and how you use it may actually tell you whether you've got a leak and all you're doing is pumping mains water back into the ground. Very, very laudable, very notable that is, but it gives you an idea. Or alternatively, if you're supplying your neighbourhood with water. So is there a cost benefit to doing this? Well, it doesn't stack up at the moment. But as sure as eggs are eggs, the government, we may be able to dodge the very significant bullet that may be carbon related by the science and the technology that we've employed over the past few years. But they'll probably get us with water, because apparently water is the new carbon. The final thing is, if you do all of this work for what it costs to get it verified, it's worth doing. Because if you have somebody coming into your works that actually can then verify that what you're saying is true, it carries much greater weight out there in the big wide world. One of the things one of our sister companies does is exactly this. So you can have your carbon footprint verified and you can have your water footprint verified. Bear that in mind. Thank you very much.